Okay, welcome back to lesson 2, which is going to be, we're going to skip ahead to unit 13, which is where really the new algebraic pieces of trigonometry come into play. Before we do anything else though, we are going to move a little bit further into just some basics and a quick review of degree and radians. Again, this is review week for you guys, so we're trying to stick with familiar concepts and just giving a little bit of a refresh on that. You might be saying to yourself, oh, Miss Moore, that's so boring. I know. You'll be okay. You'll be just fine. We'll get into it eventually. So, let's just quick get into some degrees and radians. So, I would say that in general, you guys are most familiar, and we all are most familiar with the concept of degrees. We use them a lot more when we are just discussing natural things like, oh, you did a 180. Well, that just means you turned from front to back. So in terms of degrees, we usually plot degrees in terms of this circle. So if this were going to be 0 degrees, traveling all the way around this circle would of course land us at 360 degrees. 360 degrees. It feels pretty arbitrary. It's a completely arbitrary number. No one is really sure where it comes from. Some people think maybe Egyptians, which would be maybe something to do with how many days are in a year, which would be 365. One thought is because 36 is divisible by so many factors. So 360 degrees works pretty well when you're talking about dividing up a circle into its pieces. But no one really knows. Anyway, that is the number that we're going to go with in terms of traveling all the way around a circle. So now we can divide up our circle into other degrees. If I only travel halfway around the circle, I'm looking at degrees of 180. Half of 360 is 180. If I only travel a quarter of the way, or half of a half, right there I'm at 90 degrees, which of course makes your right angle of 90 degrees. So as I travel, if I can add 90s, 90, 90, 90 more is going to put me here at 270, and then 90 more, of course, would be 360. And you can keep traveling around and around and around as many times as you want. Of course, 2 times around would then be 720, and so forth. So just a quick review on degrees. Radians get to kick it up a notch a little bit. So radians, the real question is, what on earth is a radian? So if I think about a circle, and that's what I need to think about in order to think about a radian. So there's kind of my axis. So I've got the center of my circle. I usually like to plot points like this. Miss Wheeler actually taught me this. She said, if you plot 4 points, your circle is going to be a heck of a lot better than if you just try to freehand it. And I would appreciate you not making fun of me. If you're actually taking notes with me, you can see how your circle compares to mine. Mine's pretty good, not bad. So when I think about this particular circle, just random size, 1 radian, so 1 radian measurement around this circle is going to be, actually, it's going to be an angle formed by an arc that's the same length as the radius. Okay, let me draw that first and then I'll write it out again. So 1 radian is going to be the angle formed by an arc. Now, if you think about an arc of a circle, an arc is going to be the distance traveled on the outside of a circle, or that little piece. So if I think about the radius of this circle, this is going to be my radius, r. How's that orange showing up? Pretty good, not bad. That's radius r, and let's say that it is this length. Now, if I try to take that radius and extend it up along the circle, I don't know, does that look about? If I kind of fold it along the circle, that looks about the same length. If I were to straighten this out, it might be the same length as that. And what I've done here is I've formed an arc of the exact same length, which is length r. This angle formed here, this theta, there again is that Greek letter again, that theta is going to be the equivalent of 1 radian. So 1 radian is going to be the angle formed by an arc the same length as the radius. Okay, now the size of the circle doesn't matter at all. I could have a big, huge circle. I could be like, okay, well, what about this one? What if I have this big, huge circle? Oh boy, this one's just gonna be bad, but whatever. I'm trying to go with a 30-minute video here, so I'm just gonna go quick. Wow, that didn't even connect. All right, so there's my big circle. And now this time, let's say, oh my gosh, look at that. Look how huge that radius is. That's probably twice, maybe 3 times the length of that radius. Okay, so let's take this radius and now let's wrap this radius. Let's just like wrap this radius along this poorly drawn part of my circle. And once again, you can see if you're talking about an angle measurement, if that's your radius wrapped around, that's exactly the same angle. We've got similar pieces here. This angle, we have discovered that 1 radian is equivalent to approximately 57.3 degrees if we were to put it onto a degree scale. And that's going to happen regardless of the size. Okay, fine. So last time we built our circle with degrees. Let's build it with radians. Okay, so let's say we've got 1 radian gets us to here, or about 57.3 degrees. What if I wrapped that thing around again? Well, I'm just going to keep going. So I'm going to go, what about 2 radians would put me here? So this one, 2 radians right here, this is going to be 2 radians, or approximately 114 degrees. So I'm sitting over here. All right, 3 radians. If I go once, another one, so I have another arc length of about the same. That's going to put me here. So 1 radian, 2 radians, 3 radians puts me almost halfway around the circle. Whoops, there we go. Almost halfway around the circle. If you convert this to degrees, 3 radians is actually going to be approximately 171.9 degrees. Ah, we know this is 180. Oh, wait a minute. If I go halfway around a circle, 1 radian, 2 radians, 3 radians, and a little bit. Wait a minute. What does that remind you of? 3 radians and a little bit. 3 radians and a little bit is approximately 3.14159, blah, 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 blah. Approximately pi number of radians. Cool. So pi number of radians, if I began back here at 0 radians and then went 1, 2, 3 and a little bit, this ends up at pi number of radians. So when I think about a circle, pi is going to be the number of radians traveled when you go halfway around the circle. Well, how many radians are traveled when you go around the full length of the circle? There's your 2 pi. As you can see, I love this kind of stuff, and I am so sad that we're not together so that I can really nerd it out at the board. But this is going to have to do. Okay, so quick review on degrees, going all the way around 360. Quick review on radians. I would like to now put this onto one big combo circle, which of course you guys should remember, or maybe not, as being what we like to call the unit circle. We're not going to do too much with the unit circle today, but I am trying to divide up your lessons as manageable as possible. And I think if we at least go through angle measurements today, it's going to be make the next lesson a little bit more doable. So what I have here is another blank sheet of paper. I have my 1.5 billion colors because that's how I roll. And what I really want to do is I want to think about the degrees and radians like we just talked about. And I want to start building our unit circle, which of course has degrees and radians both built into that unit circle. So I'm going to make a large axis right down the middle of my paper. We have templates for you guys linked online. But once again, I don't have a good printer at home, so you might be in that same boat where you don't have a good printer at home, which means that this would be a wonderful way for you to practice your unit circle. So here, I'm just going to do the unit circle, angles only. Angles only, and I'm looking at degrees and radians. Okay. And I'll kind of bounce back and forth a little bit between degrees and radians. We are going to be working with the unit circle for the next 3 lessons, this lesson and then 2 more. So please don't feel like you have to be an expert today. I'm just unrolling a little bit of it to make our next lesson a little bit more manageable. So let's start in degrees. I'm sticking here with my handy dandy black marker because I'm going to do what I like to call the big 4. So I've got 0 degrees here. We know we're going to start out here. Our unit circle, again, remember, has a radius length 1. Okay, so if I've got 0 degrees here, how many degrees are going to be straight up? 90 degrees. We've rotated 90 degrees. And now again, radius of the same length, another 90 degrees is going to be your 180 degrees. 180 plus 90 more, of course, is going to get you down here at 270. And then all the way around, there's your 360. Now, my kids always ask me, do we have to memorize the unit circle? No, I would suggest you never memorize the unit circle. I would suggest you build the unit circle every single time because it's got a lot of pieces. And if you understand the patterns for building, then you don't have to memorize anything. But that's just me. Okay, so now let's go through and let's build. It's usually easier to build kind of halves, so taking half of something. Okay, let's think about, I'm still going to stick with degrees for now. What's half of 90? Well, half of 90 is going to be 45, and I can eyeball that. I'm not going to be too picky here. We're more concerned with our values as opposed to our actual protractor type stuff. So this one, whoops, this one here is going to be 45 degrees. I've got half of 90 makes 45. Okay, so I've got 45. 45 more. Okay, what's 45 more? What's going to be over here? You know what? I'm just going to draw them all in first. So if you've got your highlighters, let's go draw all of our 45s as you travel around that unit circle. This one looks a little long, but you know. Okay, so I've got 90 and 45 more, which means I'm sitting here at 135. Plus 45, 180. 180 plus 45 is going to be 200, 225. See? I'm not memorizing, I'm building. 225 plus 45. 270 plus 45 puts me 315. And then another 45 more is 360. So all of these are going to be your 45s in terms of important pieces on the unit circle. Okay, well, let's switch to radians real quick before we go too much further. So my radian measurements, I'm going to write them right next to them. I'm going to choose a different color. So 0 degrees is going to also be 0 radians when I think about that. Wow, that doesn't look like a different color. That's right, I'm going to go with it. So I've got my 0 radians. Okay, we already talked about if this is 0 radians, then that means that all the way around 1, 2, 3 and a little bit, we talked about this being pi radians is going to be halfway around that unit circle. Okay, and then another halfway around is going to get you to 2 pi, all the way around that unit circle. Okay. Well, now let's think about those halves that we made. Okay, so if this piece is pi, well then what about half of that piece? How much is that going to be? Awesome. That's going to be pi over 2. Good job. Okay, well, wait a second. If that's half of a pi, how much is this little slice of pi? Oh, yeah, 1/4 of a pi, or pi divided by 4. So we've got 1/4 of a pi, half a pi. Wait a minute, I've got 1/4, 2/4. That means that this one is 3 pies, or 3/4 of a pi. Okay, I'm going to keep building here. I've got 1/4, 2/4, 3/4, 4/4. Isn't that really 4 quarters? 4 quarters. Well, that's just pi. 4 over 4 is pi. Awesome, keep building. So I've got 4 quarters. What's 4 quarters plus another quarter? There's your 5 quarters, or 5 over 4 pi radians, 5 pi over 4. That's 5 pi over 4. Wait a minute, this one down here, that means this one is 6 pi over 4. Wait. People are going to laugh at you. 6 over 4, that can be reduced to 3 pi over 2. All right, keep going. I've got 6 over 4, which means I've got 7 over 4. Can't be reduced, so I'm going to say 7 over 4. All the way around. Wait, we already know that's 2 pi. But you guys, isn't that really just 8 over 4? 8 pi over 4. Yeah. Perfect. 2 pi. Okay, so now we've got more of our pieces here, and no one's memorized anything. We're just building. Okay, but we only have halves and quarters so far. What other pieces have been important to a unit circle? Anyone? My dog does not know. Okay, how about if I take it into tinier slices? 45s are important, but also even tinier than that, what about 30s? So let's say we slice this into a whole bunch of 30s. Here's a 30. That's a really, really tiny angle. That's going to be my 30-degree angle. Okay, wait a second. 30 and another 30. Well, that one's going to be 60. Okay. I got this from Mr. Foster. I like the way he builds this. Okay, 60 and another 30. Well, that's a 90. Okay, what's 90 plus another 30? 90 and another 30. Well, there's your 120. Okay, 120 and another 30. There's your 150. And 150, well, there's your 180. Okay, so now we have all these 30s up here. Okay, I'm going to do the same thing down here. I've got 30 more, 30 more, 30 more. Videos are kind of awesome because you can just stop me and catch up a little bit, unlike class. All right, so I'm still going to build all my 30s. So I've got 30 more. What 30 more than 180? I'm at 210. 30 more, I'm at 240, and I can use that to check. Yeah, I did that right. Now I'm at 270. 270, and I'm at 300. 300, I'm at 330, and 30 more. Okay, boom, 360. So just with building like that, I didn't memorize anything, you guys. I'm just adding. So much easier. Okay, radians do get a little bit trickier. All right, so in terms of radians now, I'm gonna put my radian measurements out here. I think that might be a little bit easier to see. Here's my radian measurements. And again, pause me if you need to pause me. Back it up. I'm trying to make these videos 30 minutes or less, which you know is tricky. Sometimes we go bell to bell. Okay. All right, so there's all my radians. Did I miss anybody? I don't think so. Okay, so when I think about these slices of pie, I need to try to just focus in on these, on the orange slices. So if you take 180 degrees and you divide it into 30-degree slices, wait a minute, if I have 180 divided by 30-degree slices, I've got 6 little slices in this pie. Okay, if I have 6 little slices in this full pie, that means that this teeny tiny little slice right here, that is only going to be 1/6 of a pie, or pi over 6. That's one little slice. Okay, let's do another slice. Okay, 1/6, 2/6. Wait a second, 2/6. People are gonna laugh at me. 2/6, that's just 1/3, or pi over 3. Okay, let's do another 6. So now I got 3/6. Wait, 3 out of 6, isn't that just 1/2? Sure is, don't even need it. All right, 4/6. That's gonna be 2 pi over 3 if I reduce. 5/6. All right, there I am. My half a pie. Okay, you'll notice that your tall angles, your 60s, end up being thirds. So if I split it into thirds, there's 1/3. Now I got another 2/3, Wait a second, a third of a pie is big. 3/3 is right there. That's perfect, let's keep going. If I have 3/3 here, where's my next third? This one down here, that's gonna be 4/3. Ooh, I did skip that one. Get my highlighter out. 4/3, all right, let's keep doing big slices. 4/3, 5/3. Those are my big slices. I love those. Wait a minute. 5/3, Miss Moore, 5/3. Okay, 5/3. Now I got another third that takes me all the way around. Wait a minute. All the way around is 2 pi. But isn't that really 6/3? Yes, of course it is. Boom, boom, 2 pi. All right, cool. Keep going. We have 2 slices left. Ooh, they're just tiny. They're like the tiniest little slices of pie you ever did see. Don't even waste my time with a slice of pie that small. So this slice of pie, these are going to be my 6ths, my tiny little slices. Now here I know that's 6/6. That's a full pie. What's 6/6 plus one more slice? You're right, there's your 7/6. A full pie and a little tiny slice. Okay, you can waste my time if it's a full pie and one more slice. I will gladly take that. All right, let's go way over here to this one. Wait a minute. 2 full pies is how many 6ths? That's hard to say, 6ths. That's 12/6. Well, take away a slice. Let's say someone steals it, someone eats it. If I take away a slice, I'm over here at 11 pi over 6. And here's where you can start to see your patterns. You can see your thirds are gonna be your big chunks of pie. There's your thirds. Your 6ths, look how teeny tiny those are. Those are just little slices, but they're all 6ths. More than a full pie, less than a full pie. And look at all your 45s. All your 45s are 4ths. That kind of helps me remember those. Okay, so here's kind of the building blocks for your angles for the unit circle. And again, remember, this is going to be our review on degrees and radians, and we can't talk degrees and radians without unfolding that unit circle a little bit. If you need to rewatch that part of the video, go for it. It's also everywhere online, so that would help you a little bit. So we've got these little tiny 30s and these medium 45s and kind of those large 60-degree angles there. Okay, I got one more thing to share with you here, and it's only been 22 minutes and 26 seconds, so I'm doing pretty good. So one thing that we can do with all of this information, of course, is we can convert back and forth between radians and degrees. So radians to degrees and back again, or whichever one you're given. So we're going to work a little bit today on your practice problems, not on the unit circle, although you could use it, but just to kind of convert back and forth between radians and degrees. So maybe let's start with the unit circle as long as we're staring at it. So what if I were given, let's be given 5 pi over 4. Okay, 5 pi over 4 is given to you in radians, which means I need to convert to degrees. Now wait a minute. I need to start thinking 4 is definitely going to be one of my 45s. 5 pi over 4 is definitely more than a full pi. So I'm going to start thinking about the unit circle like this. So I'm going to go more than a full pi, one of my 45s. I can also look right here for today because I'm just kind of getting used to this. So I've got 225 degrees. Boom, done. Number 2. All right, what if I want to go negative 180? Whoa, you can go negative? Of course you can go negative. All right, if I can go positive 180 counterclockwise, negative 180, wait, I'm going to draw my little picture. Negative 180 is going to take me back that direction. Well, negative 180 lands me here, which is here. That's just pi. But I've traveled in the negative direction, so you need to make sure that you answer in the negative direction. All right, number 3. Let's do another negative. Let's go negative pi over 6. What if I go backwards pi over 6? Okay, wait a second. I'm starting here. Remember, pi over 6 is a pi divided by 6 people. That is the tiniest little slice you could imagine. Again, don't even waste my time. Tiny little slice. I'm going back a teeny tiny little slice, which means I'm only going back 30 degrees. That's one of those angles that's going to be stuck in my head. All right, let's do a tough one. I'm going to go with, how about 5 pi over 2? What if we start with 5 pi over 2 radians, which means I would like degrees. Okay, wait a minute. 5 pi over 2, how many times does 2 go into 5? 4 times. Okay, so wait a second. That's going to be 4 full pies and then a half a pi. Or you could simply count half pies. This kind of reminds me of our imaginary numbers, right? So if I'm going to count half pies, I want 5 of them. So I'm going to go 1, 2, 3, 4, 5 half pies, which means, did I say it goes in 4 times? I'm an idiot. I'm sorry. It goes in 2 times to make 4. So I'm going to end up right back here, which 5 pi over 2 is really all the way around 4 pi over 2. And then another one, 5 pi over 2. Well, isn't that just a 90-degree angle? Well, yes, of course. But it's more than a 90-degree angle. It's going to be 360 plus your 90-degree angle. So be careful about that one. That's going to end up at, what's that going to be? 450 degrees. Cool. Okay, so what happens if you're given an angle measurement that's not one of our beautiful starting to build the unit circle angle measurements? Okay, fair enough. Well, you have to think about the connection between degrees and radians. Well, our main connection between degrees and radians is that pi is the same thing as 180 degrees. That's going to be our easiest conversion. Which means if you're going to convert this, let's say that I was given, so here's a little different practice set. Let's say that for this one, the first one that I'm going to be given is maybe 25 degrees. 25 degrees does not live on this unit circle. 25 degrees is going to be here, which is going to be less than the tiniest slice of pie that I would not prefer, which means I'm going to have to break this down a little bit more using my conversion. Okay, well, I know that there are pi radians in 180 degrees. I know that if I multiply by this ratio, my degrees will divide out, and I will end up with 25 pi divided by 180. Well, I'm sure 5 divides into both of those. So my final answer here is going to be what? 5 pi over 180 divided by 5. I know, Matthew, you've already figured it out. Thank you. 5 pi over 36 radians, which is going to be a smaller slice of pie than that one. All right, let's go the other direction. Number 2. I still have 2 minutes left. Yes. Let's say if I give you something like pi divided by 7. Pi divided by 7, again, a tiny slice of pie. Let's use our conversion here. And this time, if I want to end up with degrees, we're going to multiply by 180 degrees in pi radians. Okay, well, as I multiply across, I can see pi's divide out, which means I end up with 180 degrees divided by 7, which actually ends me up at 25.71 degrees, which is pretty cool. Hey, what about 1 radian? What if I just have 1 radian? It doesn't even say anything about a pi. Okay, well, I can have 1 radian. If I want to convert to degrees, I'm going 180 divided by pi radians. Okay, so in my calculator, I'm going to do 1 times 180 divided by pi. Okay, I don't even need to do 1 times 180, but I'm going to. 1 times 180 is 180. And then I'm going to divide it by pi, which means 57.3. Okay, 57.3 degrees. Wait a second. Just wait. 57.3. Wait a second. We already decided that was 1 radian. Cool. Just shows you that that works, of course. Okay, little ones. That was a lot of information. I hope that you feel good. I hope your brain's getting back into action here a little bit. You have another bookwork assignment today if you would like to practice what we have just been talking about. Your bookwork assignment is linked onto Plan Book. It's also on your assignment sheet. Today, if you are going to be attempting the extensions, They are lengthy. There's quite a few extensions. I just want to write down some words for you. If you're going to attempt the extensions, you are going to be looking at things called arc length and area of a sector. Now, if you have your books, this is all listed in the unit before the practice problems. You can look up what an arc length is and what an area of a sector is and be just fine. If you don't have your book handy, simply look up those terms. Look up those terms online, see what you can figure it out, see what you can figure out about those extension problems. Beyond that, you guys are going to be working on radians to degrees and back again. Okay, this unit circle is a part of our future. Learn to love it. I miss you. You want to, my favorite child shot today? Excellent use of a pillow. Excellent use of a pillow. Okay. All right, goodbye, my dears. Have a great day. See you tomorrow in the Zoom if you need us.